Sorry guys, I was mute. I spoke everything and I was mute. Sorry, my bad. Okay. So yeah, so we will start the class with a recall test. Okay. I spoke for 3 minutes and I was mute. I got to know that. Okay, so I guess I'm audible, everyone. I'm clearly audible. Tell me. Yes. Okay. Okay then. So we will start the class by a recall test. Okay, I'll repeat what I have said before. Okay. So what is the answer of question number 1? Tell me, everyone. If QC is less than Kc, right? If QC is less than Kc, then the reaction will move in which direction? Yes, very good, right? It will move in. Okay, very good. So everyone know the answer. Very good, everyone. Question number 2. Tell me question number 2. So I'll just write what most of you said. So most of you said forward. Okay. Question number 2. Yes, very good. When liquid vapor equilibrium is attained, beside temperature that dash remain constant. Okay, so most of you are saying pressure. Okay, some are saying volume also. Okay, so most are saying pressure, some are saying volume. Let's see third one. We will see that third one. So the answer is either volume or pressure. That's what you guys are saying. Okay, next third one. For dissolution of gas and liquid, the solubility dash. Okay, solubility. Tell me. Yes, very good. So most of you are saying increases, some are saying decreases also, right? Let's see. Fourth one, at equilibrium, the rate of forward reaction is dash, the rate of backward reaction. This should be easy. This should be very easy. Yes, very good, everyone. Equal to, okay. So most are saying equal to, right? Next, fifth one, for dash given reaction, all the reactants or products are in same phase. Okay, very good. So everyone is sure about this one also, okay? So everyone is saying homogeneous. Let's see the answer, right? The first is forward, okay. Second is pressure. Actually, it's pressure, okay, right? Second one, it is pressure because when you talk about liquid and vapor equilibrium, right? So obviously the pressure should be equal. Okay, everyone, right? Now third one, dissolution of the gases when decrease in temperature. Dissolution is an exothermic process, okay? When we talk about dissolution, it is an exothermic process, right? And we know that in exothermic process, okay, if temperature is decreased, then the reaction will be in forward direction, okay? Right, everyone? Got it? Okay, now let's start Ionic Equilibrium. We will start with basic introduction, okay? Okay, now when we talk about this chapter, right, Ionic Equilibrium, so obviously it is almost same as your last chapter, which is chemical equilibrium. Then you should ask, so what's the difference between these two? As I said, right, when we talk about the concept in chemical equilibrium, right, just see this line. When we talk about the concepts in chemical equilibrium, right, it was basically focused on the reactants which are, tell me, which are molecules, right? They're not ions, right? What of the reaction we have studied in chemical equilibrium, they were your molecules, not ions, right? But if the reactants are ions, right? If reactants are ions, is there anything which will change in equilibrium? Tell me, is there anything which will change in equilibrium? The definition or the properties, will it change or will it remain constant? Sorry, remain same? Tell me, will it change or will it remain same? The nature of equilibrium, everything? No, everything will be same, right? That's what I'm saying. Even though the reactant is changed, the nature of reactant is changed, right? The equilibrium itself, the definition of equilibrium itself will be same, because see what is happening, only the nature of reactant is changing, right? Instead of molecules like O2, N2, you have ions, right? Na plus, OH minus, H plus, right? So H plus. So just the nature of reactant is changing, nothing else. Okay, right? So everything that we have studied in chemical equilibrium, everything is used here, right? All the concepts that we have studied in chemical equilibrium will be studied in ionic equilibrium too, will be applicable in every in ionic equilibrium too, right? So that's why whatever we have studied in chemical equilibrium will use the same thing, exact same thing. The only thing which will change is your reactant and product. Okay, everyone, got it, right? So this is the first thing that I want to tell you. Okay, so see, right, this is what it is written: the concepts and principles underlying chemical equilibrium are also applicable for ionic equilibrium, right? Okay, so everything is same, right? Everything, whatever the concept that we have studied in chemical equilibrium is same in ionic equilibrium. Okay, that it is dynamic in nature, it is independent of initial concentration of reaction, it depends on temperature only, it can be obtained from either side, the concentration of pure solid, pure liquid, right, and solvent is actually one, it does not appear in the equilibrium constant. Okay, right? Got it, everyone? Tell me. Right? So whatever we have studied in chemical equilibrium, everything is applicable, and everything holds true in ionic equilibrium. Okay, everyone, right? So this is the prerequisite that you should know. Okay, now what we talk about, what is the different that we talk about in ionic equilibrium? The first thing I said is reactant. Okay, when I said, right, the reactant are ionic, right, means they are charged reactants. Yes, tell me yes. Okay, so the first thing that we are going to talk in this chapter is, right, some fundamental terms, right, which is electrical conductivity. I hope everyone know what is electrical conductivity. Tell me. It is the ability to conduct electricity. Yes, right, everyone? It is ability to conduct electricity. Okay, now when we talk about materials or substances, they are of two types. They are of two types, right? One is non-conductor and one is conductor, that we have studied since childhood. I hope everyone know these things. Yes, non-conductors and conductors. Now when we talk about non-conductors and conductors, okay, right, when we talk about non-conductors and conductors, so we don't have to see, this is chemistry, Sneha, right? Semiconductors, right, comes, we will come under conductor only. Okay, right? So yeah, now when we talk about conductors, because we are focused only on conductors in case of ionic equilibrium. Okay, we are focused only on conductors in ionic equilibrium. Now when we talk about conductors, right, we have either metallic or electrical conductors, right? For example, copper, metal, that is what we study in physics. Then we have ionic conductors or electrolytes. Okay, so basically they are the substance of chemical mixtures which is mostly present in solution. Okay, got it, right? The ionic conductors are electrolytes. Now last is true electrolytes and potential electrolytes, right? So true electrolytes or potential electrolytes. Okay, so basically there are two difference. What is normal electrolyte, what is potential electrolyte? Now when we talk about chemical substances, so we know that mostly break into ions in the presence of, tell me, right, when dissolved in liquid or when in molten state, right? Got it? Yes. Okay, So I can say that conductors in which current is passed through due to presence of free ions, right? Free ions, okay, are called as ionic conductors or electrolyte conductors, right? Now, what is true electrolyte and potential electrolytes? Okay, so basically these are the electrolytes, right, which can conduct electricity even in molten state, right? A true electrolyte like NaCl. So basically that's the thing. When you talk about normal electrolyte, it has to be in some medium, right? In some solution, right? Okay, but there are some kind of electrolytes which can even conduct electricity. Karishma, everyone is able to hear me, I guess. Guys, everyone is able to hear me. Karishma, try to see if your login, sorry, if your audio is on. Because I'm audible and my voice is clear, okay? So we will primarily focus on electrolytes, right? Normal electrolytes, not potential electrolytes or pure true electrolytes. So basically the difference is this has to be in solution, okay? Right? Right? And this, it is just pure electrolyte, just the compound like NaCl, and they conduct electricity even in molten state. So see, NaCl can also conduct in solutions, okay? So obviously NaCl, true electrolytes can be your ionic electrolytes, okay? But all ionic electrolytes cannot be true electrolytes, okay? Okay, now there's a small term which is ionization versus dissociation. Okay, so I'll tell you what is the difference between ionization versus dissociation, right? Now, when we talk about ionization, okay, it is this NaCl, right? NaCl, when mixed in water, right? When mixed in water, it breaks down into Na plus and Cl minus, right? Okay, and then right, Na plus and Cl minus, and then it is again crowded by H2O molecules. Okay, so basically when a salt is dissolved in a solution, it breaks down into ion. That is your ionization. Okay, that is your ionization. Okay, so the process in which molecules of an acid or base or salt, when melted or dissolved in water, dissociates into ions is called ionization. Okay, right? But what is dissociation? Dissociation is just a breaking of a compound, right? Like for example, if NaCl, okay, if NaCl is broken into Na plus and Cl minus, I'm just giving an example. It can be done, it cannot be done is a question of argument. But if you're just breaking this into Na plus and Cl minus, right? So this is your dissociation. Okay, got it, right? So if you see that, right, both seems like a similar process, right? But the condition, the circumstances, right, leads to different definition. Okay. Now, when we talk about reactants, right, we talk about electrolytes. Yes, everyone, we talk about electrolytes. Okay. So let's see. Now, when we talk about electrolytes, we talk about acid, bases, and salt. Yes, everyone, right? Acid, bases, and salts, because all the electrolytes are either acid or base or salt. Now, before starting to study, right, before studying what is acid, what is base, we should know what is the categorization. Okay, because we know that in class 7th, 8th, 9th we studied a different definition of acid and base, but now there's different definition of acid and base. So is it right, or there is some mistake, or it is just different theory? So actually it is just different theory, right, given by the different scientists. Now the first theory of acid and bases was given by a scientist named as Arrhenius. Okay, now Arrhenius said that any acid, right, which releases H plus, sorry, any substance which releases H plus is your acid. Okay, and any substance which accept H plus, sorry, which releases OH minus is your base. Okay, right? Any acid which releases H plus is your acid, and when any base, any substance which releases OH minus is your base. Okay, now that's one thing. Second thing that he said is, right, when you talk about any salt, right, or any electrolyte, it will dissociate into respective ions. Okay, it will dissociate into respective ions. Okay, and their equilibrium constant is termed as Ka or Kb, depending on it is either acid or base. So whatever we have studied Kc and Kp, right? Okay, Kc and Kp, the same Kcs will be said as Ka for acid, and same Kc or Kp will be termed as Kb for base. So actually what is changed? Nothing, except for the nomenclature. It is same K, equilibrium constant is same. It's just the name is changed from Kc to Ka. So if someone asks you what is Kc, what is Ka, right? So Kc is a general term, okay, for any reaction when concentration is taken as active mass. But if it is specifically for acid, it is called as Ka. Okay, everyone, right? Okay. Now, the first prerequisite thing that you should know before starting ionic equilibrium is how the reaction, right? How the substance is dissociated. For example, H2SO4. So H2SO4 will be dissociated in 2H plus plus SO4 2 minus, right? But in reality, it is dissociated in step by step. Okay, it is dissociated by H plus plus HSO4 minus. Then, okay, it is dissociated in first H plus plus HSO4 minus, right? Then next step, HSO4 minus is dissociated into H plus plus SO4 2 minus. So this is your overall reaction. Okay, in same way, NaCl will be dissociated Na plus and Cl minus. So I hope that you know that this is the cation, this is the anion and all those things. Okay, right? Okay, everyone. Now I said that, yeah. So here I said that the substance, right, which is your salt, acid or base will dissociate. Yes or no, right? It will dissociate. Now, we have studied dissociation in case of chemical equilibrium also, which is PCl5 gives Cl2 plus PCl3, right? So is there any difference between this and this, right? So mostly no, right? Mostly no. But there are some other additional factors which will affect this. Okay, what are the additional factors? The first thing that I said is the type of substance, right? Because it is your electrolyte, right? So depending on the type of electrolyte, right, either it is strong electrolyte or weak electrolyte, that is the basic definition, right? If it is strong electrolyte, the definition of strong electrolyte is it will dissociate easily. So obviously, if an electrolyte is a strong electrolyte, the degree of dissociation will be more. Okay, so that's what the factors which will affect alpha, which is degree of dissociation, are the following. First, nature of electrolyte. Either it can be strong electrolyte or weak electrolyte. We'll discuss strong electrolyte and weak electrolyte in detail. Don't worry about that. Second, nature of solvent. Okay, now what do you mean by nature of solvent, right? Either it is polar solvent or non-polar solvent, right? Okay, so we will discuss how the solvent, nature of solvent, being it polar or non-polar, affect your alpha. Now dilution, right? How much solvent you are putting, okay? What is the amount of solvent that you have taken, and last, temperature. So we know that temperature affects Kc, so obviously it will affect alpha. Okay, everyone. So these are the factors which will affect alpha, okay, which we will study in detail, right? Now, the first thing that we studied here, right, the first thing that we saw is nature of electrolyte. Okay, nature of electrolyte. Now, as I said, electrolyte, what is electrolyte? Electrolyte are the substance which can dissociate into ions, okay, which can dissociate into ions and conduct electricity. Yes or no? Tell me. Yes or no? Yes. So I can say that obviously not all the substance, all the electrolytes can dissociate at the same rate. Yes or no? Right? There must be some substance, right, which will dissociate readily, right? And there will be some electrolytes, some substance which will dissociate slowly. Okay. Now, depending on that, we have two type of electrolytes. Okay. The electrolytes which will dissociate, right, easily. which have very high degree of ionization, okay, almost equal to 1, they are called as strong electrolyte. They are called as strong electrolyte, okay, strong electrolyte, right everyone? But on the other hand, the ions, the electrolytes which dissociates slowly, okay, which dissociates slowly and have alpha which is quite less than 1, okay, they are called as weak electrolyte. They are called as weak electrolyte. Okay, everyone. So if alpha is almost equal to 1, it is your strong electrolyte, and if alpha is less than 1, it is your weak electrolyte. Okay, got it? Anyone have any issues about the nature of electrolyte? Now, nature of solvent, as I said, solvent, right? Same thing. If solvents are ionic, means if solvents can break up into ions, they are called as polar solvents. Okay, right? They're called as polar solvents. And the solvent, right, which cannot be dissociated into ions are called as non-polar solvent. Okay, got it everyone? Now, how does nature of solvent affect the degree of dissociation? So if solvent which have high dielectrical constant, right, means it is non-polar. Okay, high dielectric constant means it is non-polar. It weakens the attractive force between cations and anions, right? So obviously non-polar solvent will weaken the solubility of, tell me, electrolyte, right? Okay, got it? So I can say that the solvent, or you can just remember like this, like dissolve like dissolve like, okay, so polar solvent, right, will dissolve, okay, polar substance more, and non-polar solvent will dissolve non-polar substance more. Okay everyone, so you just remember this line, because most of you might not know what is a dielectric constant. That's the issue here, right? Most of you will not know what is a dielectric constant, because the term which is studied in class 12th, right, for now, because it will not be asked, okay, except for the advanced exam. So you can just write down this line, that the solvent of high dielectric constant favor the dissociation of electrolyte, means alpha will increase. Okay, got it? That's it. Otherwise, most of you can remember like dissolve like. Polar solvent will dissolve polar electrolytes or strong electrolytes. Okay, and non-polar solvent will have less tendency to dissolve, right, normal polar electrolytes. Okay, now next, dilution. So obviously, right, this is something which we will study, okay, because we have a Oswald Dilution Law, which is very important concept, and we will study this. Okay, now temperature. So we know that temperature generally increases ionization, because temperature will help you in breaking off any substance. Okay, now when we talk about types of electrolytes, as I said you, right, we have strong electrolyte and weak electrolyte. Now first, what is electrolyte? Electrolytes, I hope everyone know about electrolyte. Tell me, I hope everyone understood what is electrolyte. Electrolyte are the substances which can break into ions in molten form or in solution and can conduct electricity. Yes everyone, tell me. Yes, right? Simple one line concept. Okay, now strong electrolytes, as I said, the electrolytes that can be ionized easily, right, or that can be completely ionized, okay, which means degree of dissociation is almost equal to 1, right? They are called as strong electrolytes. Okay, they are called as strong electrolytes. For example, HNO3, HCl, KOH, NaOH. How can you know that, sir, this electrolyte is strong electrolyte? You cannot know. You just have to remember. As simple as that. Okay, you have to remember that HCl is your strong electrolyte. KOH is a strong electrolyte. Okay, by solving problems, you will get to know that which electrolyte is strong, which electrolyte is weak. Okay, there's no way to know, right, for you. or actually for you, like for student like us or teachers like us, right? Because we are not doing chemical experiments to know that it is dissociating completely or not, right? So if a substance is given, if you're asked that CH3COOH is a strong electrolyte or weak electrolyte, so you have to remember that CH3COOH is a weak electrolyte. Why? Because it dissociates slowly. Okay, the degree of dissociation is less, as simple as that. How do we know that? Someone has done the experiment, someone has already told it, someone has saw that, okay, this is not dissociating as fast as HCl, that's why it is a weak electrolyte. Okay, everyone? Got it? Tell me, just raise your hand. If you got this, just raise your hand. Okay, so if you have to remember the keyword, right? Strong electrolyte, alpha almost equal to 1, degree of dissociation, right, is high, which means complete dissociation or complete ionization when dissolved in polar medium, right? See, okay, this is what I was talking about. Weak electrolyte, not completely ionized, means alpha less than 1. Okay, when dissolved in polar solvent, right? Now tell me, out of these two, which will behave as a good conductor? Strong electrolyte or weak electrolyte? Tell me, strong electrolyte or weak electrolyte? Tell me, everyone. Strong electrolyte. Very good. Very good, Akshay. Very good, Siddharth. Very good, Neha. Very good, Abhinam. Right? Very good, Ria. Both Ria Jha and Ria Singh. Right? Now, let's think about the concept of chemical equilibrium. Let's think about the concept of chemical equilibrium. We have this reactant, CH3COOH. Now, this will dissociate into CH3COO minus plus H plus. Yes or no? This is what we should know, right? What are the ions? What is cation? What is anion in a electrolyte, right? So this is an acid. So we know that acid will dissociate into CH3COO minus plus H plus. It will release H plus. Okay. So this is a reaction. Now, what is the first step, right? What is the first step in chemical equilibrium? Write the reaction. This is a reaction. Second step, initial concentration. So I'll just take at 1, 0, 0. What is the third step? Concentration at equilibrium. 1 minus alpha, alpha, alpha. Got it? Tell me. So what is this alpha? Alpha is a degree of ionization. See, in chemical equilibrium, we study alpha as degree of dissociation. Yes or no? Yes or no? Right? So are they same or different? It is same, just the name has changed because the reaction has changed. As simple as that. Okay. Now, you can see that some cases alpha will be represented as H or S. Okay, right? What will change? The type of reaction will change, right? The meaning of alpha will remain same. Okay, so what is alpha? It is the amount dissociated, right, divided by total number of taken. Same, X by A, same as that. Okay, okay, everyone, got this concept? Tell me. I hope everyone got this concept. If there's anyone, please let me know. Okay. So if we see the mind map, let's see the mind map. Okay. So I can say that the mind map goes like this, right? When we talk about solution, means solute plus solvent, okay, or electrolyte. So it is of two types, okay, conducting and non-conducting, okay, conducting and non-conducting. So non-conducting, we don't have to study. Forget about that, right? Now conducting can be of two types, strong and weak. Got it, everyone? Right? Strong electrolyte and weak electrolyte. Now, these can further be divided into three types. Okay, these can further be divided into three types, which is acid, base, and salt. Acid, base, and salt. Got it, everyone? Tell me. Got it? Now, what do you think? What do you think? We are talking about which chapter? Ionic equilibrium, right? We're talking about equilibrium. So we should be talking about, or equilibrium will exist in which case? Strong electrolyte or weak electrolyte? Tell me. Equilibrium, we will study about equilibrium in strong electrolyte or both electrolyte or weak electrolyte. Tell me. Yes, very good, right? Because Strong electrolyte is completely dissociating. The reaction is in one way. It is not reversible, right? Not reversible. Okay, it's not reversible. Got it, everyone? Okay, right? So that we'll talk about weak only. Okay, so equilibrium. When we talk about equilibrium, we should have a reversible reaction. Yes or no? Tell me. We should have a reversible reaction, right? And the definition, the very definition of strong electrolyte, say that it dissociates completely. Yes or no? Tell me, yes or no? Now, if any substance is dissociating completely, can the reaction be reversible? Think about it. Can it be reversible? No, right? Okay. And we know that if a reaction is not reversible, we will not talk about equilibrium. So, right, whatever concept of equilibrium that we will use, it will be used only for weak electrolyte. Okay. For strong electrolyte, it's just normal reaction. It will dissociate completely. We will just use what? Mole concept. Simple mole concept. Right? Okay. Right? In this, we will use both mole concept, obviously, because mole concept is used everywhere. Right? In every chapter, we'll use mole concept. Mole concept plus equilibrium concept. Okay? Plus equilibrium concept. Got it, everyone? So in this, we will not use equilibrium concept at all because it is not in equilibrium. It's a irreversible reaction. Agree, everyone? Tell me, agree? Understood till this point? Getting the basics, right? Because every chapter is easy if you understand the basics. Very good, Suhas. Very good, Sneha. Okay. Very good, Akshaya. Everyone is getting very good. So let's see. So as I just said, right? When we talk about electrolyte, okay, there are two factors, solute and solvent. Okay, now I'm saying that electrolyte is the mixture of both. It is solution. Okay, so one thing that you have to keep in your mind, that electrolyte is a solution. Okay, it is a solution. So obviously the strength of electrolyte depends on solution too. Means electrolyte may behave as a strong one in aqueous solution, but it may behave as a weak in other solvent, right? Got it, everyone? Tell me, got it? Because we know that polar solvent, right, will facilitate what? Strong electrolyte, but non-polar solvent will, tell me, will not facilitate the dissociation of, yes, got it? Okay. Now, see this. We have a problem over here. Just try to solve this problem, everyone. Right? So first problem is identify the non-electrolyte, strong electrolyte and weak electrolyte in the aqueous medium of the following substance. This you have to remember. Okay. Now just think about it. Just think about it. Right? We will think about it. Right? Tell me, NaOH strong or weak? NaOH strong or weak? Or non-electrolyte? Strong. Very good. NaOH strong. HCl. Very good. Strong. NaCl. Okay. Strong. NH2, CuNH2, it's a non-electrolyte, right? It is non-electrolyte, na? Okay, it is neither acid nor base nor salt. It is a non-electrolyte. Okay, it's just a normal compound, normal non-polar compound. It is a non-polar compound. Okay, everyone. What about H2SO4? See, again, right? When you talk about chemistry, okay, I'll just give you one heads up. When you talk about chemistry, okay, so the chemistry, in chemistry, H2SO4 is like a very controversial acid. It is usually a strong acid, but in some cases it will be treated as weak acid. Okay, so keep this in your mind, right? H3PO4, it is a weak acid. Okay, got it, right? In the same way, when you talk about Tell me. When you talk about what? HCN, it is also your weak acid. So make a list now. I hope all of you got the idea. Make a list. We'll see at once. Okay. Okay, so I guess all of you understood now. So we will see the list, right? HCN, H3PO4, right? NH4OH, they all are weak component. Okay, NH4Cl, right? And NH4Cl. It is a mixture of weak and strong. So it will be your strong. Okay, got it? We will see how it is strong, how it is weak, how it is a mixture. Now, before that, I hope all of you can identify acid, base, and salt, right? Like this is base, this is acid, this is salt, this is normal compound, right? This is your acid, this is your acid, acid, base, base, acid, this is salt, right? Acid, normal compound, normal compound. I hope all of you got this. Tell me, substance having OH, right? OH minus is your base. Substance having H plus is your acid, and substance which have one cation, one anion, right? From each acid and base is your salt. Okay, right? Right, everyone? Okay, now next is Oswald Dilution Law that we have studied. Okay, Oswald Dilution Law. Now, everyone, please focus here. Okay, or remember, forget about this for now. We'll just try to use this. Okay, Oswald Dilution Law. Okay, now think about this, right? Before studying any law, right, just think about this. We have a reaction. Suppose we have a reaction HA. Okay, HA. What is HA? HA is a weak acid, because obviously we'll talk about weak components only, right? Right, everyone? Yes or no? Right? Now HA will break into what? HA will break into what? Tell me yes, very good. H plus plus A minus, yes or no? H plus plus A minus, very good. Now, forget about ionic equilibrium. Just remember the concept of chemical equilibrium. Suppose initial concentration of HA is C, then it will be 0, 0. Yes or no? Tell me yes or no. Right? At equilibrium, what it will be? It will be C minus C alpha, right? It will be C alpha, and this will be C alpha. Okay? Everyone agree with this? Everyone agree with this? Right? Okay. Now, what is Kc here? Tell me, what is Kc? Kc is equal to what? I'm just using the concept of chemical equilibrium. That's why I told you, if you actually understood chemical equilibrium, everything would be easy. Kc is equal to what? Tell me. It will be C alpha into C alpha divided by C bracket 1 minus alpha, right? So it will be C alpha square divided by 1 minus alpha. Agree? Agree, everyone? Tell me yes or no. Yes or no, right? Now, yes, very good. Now, as I said, for acid, okay, for acid, Kc is called as Ka, okay. Now, suppose alpha is very less. Suppose, right? Okay, assume alpha is very less than 1. Okay. Yeah, 1c is cancelled. Na Sneha, 1c is cancelled, right? 1c is cancelled. That's why it is just 1 minus alpha. Na? It is c squared by c. So 1 is cancelled. That's why we have 1c here. So assume that alpha is very less than 1. So can alpha be ignored in the denominator? Tell me, can alpha be ignored in the denominator? Yes. But in numerator, no, because in numerator is multiplied, right? We ignore 1 plus 0.000001. It is almost equal to 1, right? So obviously it is ignored, right? It is ignored, tends to 0. But if it is 1 into 0.000001, can you ignore this? No, you cannot ignore. Got it? Right? Okay, very good. So Ka can be written as C alpha square. Yes or no? Anyone have any issues in this? Tell me, anyone have any issue in this? Right? Don't you think that this is what we have been doing since last chapter? Yes. So if you are asked to find alpha, can you find alpha? Alpha is equal to root Ka by C. Yes or no? Yes or no? Anyone have any issue in this? So if I say that degree of dissociation is inversely proportional to root of the concentration of the electrolyte, will it be correct? Will it be correct? Right? For weak electrolytes, yes, it will be correct. Yes, everyone? Okay? Okay, everyone. I hope everyone is understanding this. Now, let's see what is Oswald Dilution Law. Now, Oswald Dilution Law, right? Just try to read the statement. It say that, wait, what happened? Okay, the application of law of mass action, right? Law of mass action we have studied in, tell me. Law of mass action we studied in which chapter? Last chapter, right? The application of law of mass action, okay, to weak electrolyte is called as Oswald Dilution Law. As simple as that. Okay, as simple as that. Right, everyone? So I can say that, okay, the application of law of mass action to weak electrolyte is called as Oswald Dilution Law. Okay, right? And I can say that the degree of dissociation will be inversely proportional to concentration, square root of concentration. Okay, got it, everyone? Tell me, got it? Yes or no? Yes or no? Anyone have any issue in this? Anyone have any issue in this? No? Right? Very good. Very good, everyone. Now, why it is called as Oswald law of dilution? So we know that alpha is inversely proportional to 1 by root C. And we know that C, concentration, is inversely proportional to volume. Yes or no? Is inversely proportional to volume. Right? So if you use these two, can I say that? That alpha will be directly proportional to, okay, this is alpha and this is directly proportional to root V. Tell me yes or no? Yes or no? Yes. So this says that if we increase the dilution, right, of weak electrolyte, the degree of dissociation will also increase. Okay. Yes. Agree. Okay. Now condition. Can it be used for strong electrolyte and when alpha is almost or less than very less than 1 means it is, suppose if alpha is equal to 0.5, can I use this formula? Alpha is equal to root of K by C. Can I use this? No, because alpha is not, yes, alpha is not very small than 1. Okay, so that is one thing. Oswald dilution law is only applicable for very weak electrolytes. Okay, got it? right? Means 1 mass alpha should be almost equal to alpha will be used only when alpha is 5%, which is alpha should be less than 0.05. Okay, everyone, tell me yes or no, right? So your question should be, sir, what we will do? What we'll do if alpha is not less? No issues, right? You have Ka is equal to C alpha square by 1 mass alpha. So value of K will be given, value of C will be given. You have a quadratic equation. You will have a quadratic equation solved. Okay, solve for that quadratic equation. Okay, now this might be very difficult. Okay, but again, in chemistry, you have to solve difficult equations, right? Because that is the only thing that makes the calculation difficult. Okay, got it? Right? Right, everyone? Now, what about strong electrolyte? Strong electrolyte will be easily dissociated, no issues, like NaCl, right? If NaCl is 1 mole, then Na after dissociation, Na plus will also be 1 mole and NaCl minus also 1 mole. No need of equilibrium. Yes or no? No need of equilibrium, right? Okay? Okay, very good, right? Now, just try to solve this problem. Just try to solve this problem. Question number 2. Everyone, try to solve question number 2. Right, everyone? Okay, let's see what concentration of acetic acid is needed to give a hydrogen ion concentration of this, right? Now just see this, right? Now in this problem, right? In this problem, what is given? Okay, just see this. Alpha is equal to 3.5 into 10 to the power minus 4 and Ka is equal to 1.8 into 10 to the power minus 5. Right, everyone? Tell me yes. See? Okay, yes. Now, what do you think? Alpha is very less, yes or no? Alpha is very less. Okay. Now, yeah, instead of alpha, hydrogen concentration is given, which is C alpha is given. Okay, right? Sorry, my bad. Instead of alpha, C alpha is given, right? No issues at all. So I can say that, yeah. So using this, we have K is equal to what? Tell me everyone. K is equal to 1.8 into minus 5, which is given. This is equal to C alpha square. Yes, C alpha square, which is equal to what? C alpha into alpha, right? Now, C alpha you know, K you know. Can you find alpha? Or you know that alpha is equal to root K by C. Then C alpha is equal to root Ka by C into C, which is equal to root Ka into C, right? C alpha. So you can just use this also directly. Yes or no? C alpha is given, K is given. So C can be said as C alpha whole square divided by Ka. Yes or no? Tell me. Yes or no? Tell me, everyone. Okay. Now what is C alpha? Just put the value. Just put the value here. What is C alpha? It is 3.5 into 10 power minus 5 divided by, now square, obviously I'll do square, right? So 10 power minus 4 square divided by 1.8 into 10 power minus 5. Okay, so obviously you have to think about the approximate answer. Okay, now when you talk about approximate answer, which is 3.5 into 3.5 into 10 to the power minus 8 divided by 1.8 into 10 to the power minus 5, right? See this, it is almost 2, yes or no, right? But a bit less than 2. Now it is 3.5, okay? Now 3.5 into 2 is almost 7, but bit less than 7. So it will be 6.8 or 6.9, right? Approximation. Now this 10 power minus 8 minus 10 power minus 5, which is equal to 10 power minus 3 into 10 power minus 3, right? So answer is B. Got it? Right, everyone? Right? Approximation. Okay. Okay. So I guess all of you understood what is the basic definition, right? Okay. Now, what is the limitation of Oswald Dilution Law? Again, it is only applicable only for weak electrolyte. Okay, right? Got it? When alpha is very, very less than 1. Now, if alpha is not given, if we are finding alpha, then how can I say that this alpha is neglected? So you have to see Ka also. If Ka is less than 10 to the power minus 5, right? If K is less than 10 to the power minus 5, then you can ignore alpha. Okay, think about this. If alpha is less than 10 to the power minus 5, then you can ignore alpha. Can, it is not always, right? Remember this, because there's other factor which is concentration. Okay, we will see those issues. Okay, now concept of acid and base. Again, this is about acid and base because we are talking about electrolytes. Yes, everyone. So till now, I hope all of you understood the basics. What is electrolyte? What is strong electrolyte? What is weak electrolyte? What is Oswald Dilution Law? Right? What is degree of dissociation? Right? How to find degree of dissociation? Okay. Now, so after this, we will study, as I told you, we will study in detail about the concept of acid, base, and salt. Right? Now, acid, base, and salt are actually, or basically, acid and bases are categorized into 3 types. Right, everyone? First is Arrhenius, second is Lewis, third is, sorry, first Arrhenius, second Bronsted-Lowry, third Lewis. Okay, so I can say that, wait, okay, so I can say that acid and base, okay, can be categorized into 3 categories, okay. First is Arrhenius, wait, yeah, so is acid and base can be categorized into 3 types. First is Arrhenius, given by Arrhenius. Arrhenius acid and base. Spelling is wrong, I guess. Arrhenius, it's double R H. It's not E. Okay, Arrhenius acid and base, right? So in Arrhenius acid and base, right, the scientist named Arrhenius said that if any substance release H plus, it will be your acid. It will be your acid. Okay, and if any substance release OH minus, it will be your base. As simple as that. Okay, got it? So this Arrhenius concept was based on the release of H plus and OH minus. Okay, it was based on release of H plus and OH minus. For example, when you talk about this HCl or CH3COOH, so I can say that these two are releasing H plus, right? on dissociation, right, or ionization, they're releasing H plus. So they are your acid. Okay, for example, HNO3, HClO4, HI, HBr, H2S4, all are acid because they're releasing H plus. Okay, now in the same way, right, if it releases OH minus, it will be your base. Now depending on the number of H plus and OH minus released, depending on the number of H plus and OH minus released, it is either, okay, it is either your monobasic, right? So monobasic, see, monobasic means release of one H plus, right? Remember this. Okay, basic, monobasic is used for acid, okay, and monoacidic is used for base. This is one opposite nomenclature which is used here. That's you should remember, okay, right? So mono means one, basic is H plus, monobasic if one H plus is released, diabasic 2, tribasic 3. Okay, now this H plus, right, this H plus is your called as H plus, which is released, is called as exchangeable hydrogen, exchangeable hydrogen, right? Now what is the meaning of exchangeable hydrogen, right? So these hydrogen or acidic hydrogen. So what is the meaning of exchangeable hydrogen or acidic hydrogen? So the hydrogen which is attached to high electronegative atom, hydrogen attached to higher electronegative atom, higher electronegative atom. Electronegative atom. And what are the high electronegative atom? Fluorine, oxygen, nitrogen, right? These three. And you can take chlorine also. Okay. They are called as high electronegative atom, right? They are called as acidic hydrogen. Okay. For example, if I'm saying CH3, will this OH, how many hydrogen do we have here? Tell me. How many hydrogen do we have here? Tell me everyone. How many hydrogen do we have here? 4, right? 4 hydrogen. But which is the exchangeable hydrogen? Tell me, how many exchangeable hydrogen do we have here? 1, right? Got it, because this is your exchangeable hydrogen. Okay, only this is your exchangeable hydrogen. This is not, these three are not your exchangeable hydrogen. Okay, everyone? Right, everyone? Got it? Okay. Now, again, there's exception of this also, so don't worry. Till we are studying organic, we won't be worried about this exceptions, okay, but that's why I'm using the term exchangeable hydrogen, not acidic hydrogen. Okay, it may be called as acidic hydrogen, but exchangeable hydrogen is the best term. Okay, exchangeable hydrogen are called as your acidic hydrogen. Okay, now H3BO3 is not your Arrhenius acid. Why? So these are some exceptions that you have to remember. Okay, these are some exceptions that you have to remember. Okay, everyone, right? These are some exceptions that you have to remember, right? Just note it down. Okay, now in the same way, Arrhenius base are the bases which reduces OH minus. Okay, right? It reduces OH minus. Now, when we talk about OH minus, so obviously after removing OH minus, right, we will get anion, OH minus, and then cation, right? This is your usually metal. Okay, right? Now, in this case also, we have monoacidic, diacidic, triacidic, depending on number of OH minus released. Okay, got it, everyone? So see the nomenclature: acidic, monoacidic base, right? It is used for base. Acidic base is, what is the meaning of this? OH minus, release of OH minus. Okay, everyone? Okay, now see, there's one point which you have to remember: H plus right? Whenever you see reaction, H plus can also be written as H3O plus, right? H5O2 plus. So what is this? Basically, H plus exists with water. Okay, H3O plus means H2O plus H plus. H5O2 means, right, H5O2 plus, H7O2O3 plus, these all are the representation, right? H2O whole twice plus H plus. Okay, so this is your representation, as simple as that. Then what is hydronium ion? Hydronium ion. Okay, hydronium ion, right? So you can either write like this or H plus, doesn't matter. Okay, H3 plus means H plus only. Okay, everyone? Okay, sorry, I got a call. That's why I have to leave and join again, right? So that's the case of hydronium ion, right? H plus. Now, in the case of base also OH minus can also be represented like this. Okay, right? So both are same. Instead of H plus, if you see H3O plus, or instead of OH minus, if you see H3O2 minus, right? Both is same. This means H plus, and this means OH minus. Okay, everyone, right? Okay. Anyone have any issues? Tell me. Anyone have any issues? Clear. Okay. Now let's think about this. We know that H plus plus OH minus will give you H2O. This is one famous reaction. I hope everyone remember this, right? But is it possible Na plus plus Cl minus gives NaCl in presence of water, obviously, in presence of H plus plus OH minus, right? When you talk about neutralization, right? Is this possible? Can Na plus and Cl minus combine again to form NaCl? Yes or no? Tell me, yes or no? That's it. We have Na plus plus HCl plus Cl minus, right? Or I'll just give you like this. We have reaction NaOH plus HCl. This is your neutralization reaction, yes. So this will form NaCl plus H2O, right? Okay, no issues. But if I'm again giving Na plus plus Cl minus, if I'm again giving H2O, right? Okay, will it form NaOH plus Cl minus? Tell me, yes or no? Will it again form NaOH plus HCl? No, no. Very good, right? Very good. See, because it is your strong acid, strong base. Okay, right? Strong acid and strong base. It is irreversible. Means once NaCl is formed, it cannot further dissociate into Na plus plus Cl minus. Okay, right? That's what you have to remember. So if we have Na plus and Cl minus, it will be in that form only, right? Okay, it will not again recombine. Okay, next, strength of acid and base. Again, strength of acid and base. Just think about this, right? Just think about this. If you have more H plus, think about it. If we have more H plus, it will be strong acid or weak acid? Tell me, it will be strong acid or weak acid? If you have two acids, right? One produces more H plus, one produces less H plus. So which of them, which of them will be strong? Which of them will be weak? Suppose we have A and B. A is producing more H plus as compared to B. Which of them will be strong? Yes, very good. Obviously, right? Yes, A will be strong, Ria. A will be strong. Okay, because if an acid is dissociating more, it is producing more H plus, it will be a strong acid. Okay, so when you see this, right? When you see this, okay, so this is what we have done, right? Ka was concentration of H plus into concentration of A minus divided by concentration of Ha. Yes or no? So if Ha concentration is more, Ka will be more. Tell me yes or no. If H plus concentration is more, Ka concentration will be more. Now, this is not this K. I'm comparing K of A and K of B. Okay, right? I'm saying if I've taken same amount of, suppose I'm taking another acid, HB. Okay, so this is Ka1, and suppose we have Ka2, which is concentration of H plus into concentration of B minus divided by concentration of HB. Okay, now you take same amount of HB and same amount of HA, right? Obviously, if H plus of Ka1 is more than H plus of Ka2, then I can say that Ka1 will be more than Ka2, right? So Ka1 will be stronger acid, right? Okay, as compared to Ka2, right? So I can say that if Ka is more, acidic strength is more. Strength is more. Okay, okay, everyone. Tell me, and can I say the same thing about base? Can I say the same thing about base? If Kb is more, right? If Kb is more, basic strength will be more, right? Similar thing can be said for base, right? If OH minus is more, then Kb is more. Okay, right. This was Arrhenius. So what was Bronsted-Lowry? So Bronsted-Lowry theory was almost same as Arrhenius, almost. But the issue or the difference is in Arrhenius, right? Arrhenius took the definition, right, on the basis of H plus and OH minus both. Okay, H plus and OH minus both, on which the Bronsted-Lowry said that what about those substances, right, which is not having OH minus, right? Can they not be your base? Okay, so he said that, okay, instead of having H plus and OH minus, he just took H plus. So he said that any acid or base, right, depends on either giving of H plus or taking of H plus, right? Means if any substance give H plus, right, releases H plus, it is your acid. But if anyone accepts H plus, then it is a base. Okay, everyone, got it, right? I hope all of you have already studied this in junior classes, but again, I'm just revising. Okay, so I am saying that we have substance which release H plus is your acid. Substance which accept H plus is your base. Okay, so according to this definition, we can have a substance which can either be base or be acid. Yes, it is possible. Okay, got it, right? Now think about this. This concept, this Bronsted-Lowry concept gave us the idea about conjugate acid and base pair. Conjugate acid and base pair. What is the meaning of conjugate acid and base? Just see this, right? Just see this. Okay. Now here we have what? Here we have HX, right? Here we have HX, okay, which is certainly an acid, and B, which is your base. So B minus it will be, or B minus, let it be B minus or B, okay, doesn't matter, right? Now H plus will be released and it will be accepted by B. Now if H plus is accepted by B, now we have HB, right? I'm taking at B minus, so it will be HB, okay, for better understanding of actual problems. Now what do you think? HB is your acid or base? Tell me, HB is your acid or base? Tell me, everyone. HB is your acid or base now? It is your acid, right? Now this is called as conjugate acid. Okay, so this HB is a acid, conjugate acid of base B. That's what it's called as conjugate acid. In same way, HX was acid and it became X minus. So it is a conjugate base. How it is conjugate base? Because now X minus have tendency to accept H plus. Yes or no? Now X minus will have tendency to accept H plus. So it is acting as a base, right? So it is a conjugate base. So I hope all of you understood the concept of conjugate acid base, right? If you understood, just tell me this. Okay, got it everyone? I think all of you got this, right? So these are some examples. Everyone just go through some examples. See, HCl plus H2O, okay? HCl plus H2O. Yes, I'm repeating Karishma. See, I'm just giving some examples. HCl is an acid. H2O is acting as a base here. H2O is a neutral substance which can act as both acid and base. So, see, HCl after releasing H plus will give Cl minus, which is a conjugate base. And H2O after accepting H plus will become H3O plus, which is a conjugate acid. Okay? In the same way, HSO4 minus after releasing H plus it will form SO4 3 minus. SO4 2 minus actually. Right? There's a mistake. Now, NH3 after accepting H plus will form NH4 plus. Right? So the base after accepting H plus will become conjugate acid, and the acid, right, after removing H plus, right, will become conjugate base. Okay, everyone, understood this? Tell me, understood the concept of conjugate is conjugate base? Anyone have any issue? Tell me. Anyone have any issue? No? Very good. Preetham, Mansi is absent. Mansi is here. Okay, very good. Priyanka, Ria, both Ria, Ronak, Sai Smriti, everyone is understanding this. Sania, Samya, Shreya, till this point, anyone have any issues? Everything is clear. Very good, Ria. Very good, Sania. Very good, Samya. Tulip, are you getting everything, Tulip? Till now, we just studied, right? Basic theories only. Okay, right? At any point of time, if you feel anything, right, you couldn't get, just ask me. Okay, right? Now, just think about this relationship between acid and base. Okay, now think about this, right? Before starting this concept, right, just think about this. Suppose I'm having an acid HA, right, plus B minus, which is your base. It becomes HB plus A minus. Now just think about this. For example, right, suppose acid will form conjugate base. Yes or no? Tell me. Acid will form conjugate base. Yes or no? Yes. Now, we have two acid HA1, right? A1. Now again we have second acid, right? Suppose we have second acid HA2 plus B minus gives HB plus A2 minus, right? Now I'm saying that this A1 minus is more stable than A2 minus. A1 minus is more stable than A2 minus. Okay, right? Means the anion A minus is more stable than anion A2 minus. What do you think? Which acid is stronger? HA1 or HA2? Which acid is stronger? Think about it and tell me. Yes, Aksha, very good. Everyone think about it and tell me. See, Suhas, see this, right? Suppose A1 is stable. A1 is more stable than A2. So which acid will have more tendency to give H plus? Tell me. Obviously, which have more stable, right? Which are more stable conjugate base. Got it? Yes, very good. A1, very good. So this is one point you have to remember, right? More stable conjugate base, stronger the acid, okay? And vice versa, which means more stable conjugate acid, stronger the base. Okay, everyone got this concept? Tell me, got this concept? Okay, very good, everyone. So now we can just go through the concepts here. Okay, now when we talk about acids, so acid in water will dissociate into H plus into A minus, right? Okay, so in this one, tell me, I can say that this is a conjugate base and this is a conjugate acid, yes or no, right? Okay, now we know that strong acid will have stronger conjugate base, okay, and weak acid will have weaker conjugate base. Okay, everyone, right? Okay, now in this case, okay, I can say that HCl is a strong acid. Okay, so after giving H plus, right, right, it will form H3O plus plus Cl minus, right? Now since Cl minus is stable, right, it will not have a high tendency to accepting H plus and forming Cl minus HCl again, right? So I can say that this reversible reaction is very unlikely. Okay, yes or no? Is very unlikely, right? Got it? Or you can say that Cl minus is stable, right? Or it is a base, weak base, right? Got it? Yes or no? Because it is stable, it will have less tendency to accept H plus, right? Which means it's a weak base. Means conjugate, yes, conjugate acid of conjugate base of strong acid is weak, right? Conjugate base of strong acid is weak. In the same way, conjugate base of weak acid is strong. Got it, everyone? Got it? Right? So if you have to compare the acids, what do you have to compare? You have to compare their conjugate base. Okay, this is one concept that we will study in organic also. Okay, right, everyone? I hope everyone is getting this. I've explained the concepts, right? Now this is what we have already studied, that K equilibrium, okay, right, into H2. Why H2? Because H2 is just a liquid, right? H2 is just a liquid, pure liquid. So 1. It is also equal to Ka. Okay, right? Right, everyone? Okay, very good. Okay, so we have very less time. We'll continue with concept of Ka, Kb next class, but before that, let's solve some problems, like some problems of quiz. Okay, we have studied this concept. Now tell me this one. Which of the following are the limitation of Arrhenius concept? Tell me, everyone, which of the following are the limitations of Arrhenius concept? It only works in aqueous solution. It does not account for base which don't have hydroxyl group. Hydroxyl means OH. It does not account for acid which don't have hydroxyl group. It only applies to substance at 25 degrees centigrade. Answer is okay, very good. Just think about this, what we have studied, right? Now think about the answer is B, right? Answer is B. We never spoke about temperature, right? So how can we say that answer is D? Okay, got it? It is clearly, right? Clear that answer is B. Everyone got it? Tell me, got it? Yes, those whose answer is B. Fourth is not correct, no? It's just temperature, right? Fourth is temperature, see this, right? Okay, so obviously fourth is not the answer because it doesn't apply to substance only at 25 degrees centigrade. We haven't studied like that, right? Next, everyone tell me. H2O loses H plus to form OH minus and also accept H plus to form OH minus. Which of the following statements are true for OH minus and H3O plus? Tell me. Think about it. We have already studied this. We have already done this. Okay, Sneha, Karishma, very good. Now I'll just write a reaction for you, okay? Yes, very good. So most of you are saying correct answer. Now OH minus, just think about this. OH minus is formed after removal of H plus. Yes or no? OH minus is formed after removal of H plus. What is the tendency of OH minus? To accept H plus. So it is your base. OH minus should be conjugate base. Okay, OH minus should be conjugate base. Got it? Because it is removed after, right? It is formed after removal of H plus. Yes or no? So it is a conjugate base. Now, H3O plus. H3O plus accepted H plus, right? H3O plus accepted H plus, right? So this is your conjugate. Tell me, acid. Okay. A. Okay. I hope everyone is clear in this concept. Tell me. I hope everyone is clear. Okay, everyone. Very good. Okay. Then that's it. Okay, that's it for today's class. Okay. On Wednesday we will continue. Okay, everyone. And see, I hope all of you have given the test. If there's anyone who didn't give the test, please give it in next class till next class. Okay, right? I hope everyone understood all the concepts. Tell me. I hope everyone understood all the concepts. Okay. Okay, everyone. Bye, everyone. Thank you, everyone. Yeah. Saturday there were some issues. That's why I apologize for that. Okay. I hope that won't happen any day else. Okay, Karishma. There are some internet issues and Ashish was not there, and I was not feeling well. That's why I posted in the group. Yeah, physics. There was some issues. Okay, so